Okay. All right. So now let me show you. So we probably need some starting data examples. So let's first of all go to command to log to MongoDB. So I'll put MongoDB in here. Let's big screen here. Okay, so we have MongoDB here, and then we may need some sample data. So if we need that, you can get those from eCourse. Let me show you where they are. So if you go to, say, public, go to script loader, the same place you down you get Oracle scripts. So if you go to like there's a create a MongoDB sample collections. Okay, so here you get a bunch of sample data for us to practice. Okay, so for example, if I want to use this inventory and just copy that. So first of all, delete everything you have first, and then insert that. So why is that? Because having so much data, it will disturb our view of the data to see whether we do something right or wrong. And of course, that's just for practice, okay, for practice. But if in the real life, you don't have to do that. Just make sure you write statements. That's all you need. Okay, so that's the place you can get a MongoDB. Okay, so let me just give you some basic idea how what we need to do. Basically, when we write MongoDB queries. So I'm going to create a new slide here, new whiteboard. So we learned how to insert data. So basically, in that case, you would just go to database and then say db dot get a collections. If a collection does not exist, the collection will be created for you. For example, students, right? And then insert. Or you can insert many if you have many documents to be inserted once. So inside the function, you just need to provide documents, the whole documents. Okay, so one for each student document, right? So if you have many, then just say comma, then just put next document. So each of these document is simply just key value pair, right? So key value, comma, key value pair. Okay, and also you can embed documents inside documents, right? So that's for insert. And then for remove, it's just also kind of a symbol. So simply say db dot remove. Okay, and also parentheses. And here, inside here, you're going to provide parentheses, provide a document, and that document is called query filter document. Okay, so if you do not provide any specific document, just an empty space in here, then basically everything inside document, inside this collection will be deleted. But if you provide a specific query filter document, then only the document that meet these conditions will be removed. Okay, so that's how to do that. And then if you're going to do find, we already did that once. So for example, if I want to find a particular students, I will just do that, say db.collectionname.find, okay, and the parentheses here. And we did example with no query filters, but if you do have query filters, you put it inside here, and that is same as that, okay, query filter document. So the query filter document will specify which document to be retrieved, okay. And I'm going to explain to you what is a query filter document looks like. Make sense? And then you're going to you can also do update your students. But you can just do update. For update function, you're going to have two parts. The first part, is query document, which is same as that. So which will specify which document to be updated, And then the second part is actually just like operators will help you to say you want to change values or replace values. Then just say you want to set, okay? And then in here, you specify what field will be set in which value, and then which field will be set into which value. Okay, so key 1, value 1, key 2, value 2. So if you have more, then just continue that, and that is that's how basically you do. So you need to close that again, okay, and then parentheses to close that one. So that's how you do update. So all of them require you to know this query, so-called query field or document. How to do query field or document. Okay, so query field or document is basically just the simple ones and the more complex ones. Here, let me just do simple ones first. Okay. So query document basically just query field document. Okay. So it's kind of is document. Okay. It's also key value pairs, right? Key value pairs. Okay. So the simplest case will be just say key value equal to something. So if you want to, so for example, in our case, if we want to see if we want to see the student name is something, okay? So then we did that, right? So basically the document will be so we'll do equal case, okay? Equal. So equal case, the document will be created like this. So basically you're going to say student name, colon, and then say Jones, double quotes. There we go. So that's a very simple criteria, okay? And of course, you can have multiple criteria. So to just simply, so for example, this is let me just put it here. So as name. Okay. And what if you want to say student name is that and also something else? So let's just say we also do equal to. So if you have a second criteria, then just simply add more to the documents. So just end here. Okay. So let's say as name is equal to John's. That's equal to John. Okay. And then comma. Okay. And now let's just say gender is male. Okay, close that. So in this case, you just simply use two criteria, this and that. So this is and. All right. And what if you want to use or? Say this is this one or this one. Then in that case, you have to use so-called operator or. This or. This or use operator. This is operator. Okay. So in that case, what you're going to do is this. So you let me talk about operator just in general case. Okay, let's finish this one first. Finish the equal to first. Okay, so we'll do that. Do that next. So if you have multiple, then you end. You just keep on adding that. And what if you have like a missing values? So if something equal to missing is missing. So for example, as name is missing. So if you do as name is null. Okay, how do we do that? So in that case, you do something like this: as name colon null. So that is how you create that criteria in the document. Okay. And what about name starts with letter or ends with letter or contains letter? So let's say as name starts with say HJ. Okay. So in that case, you're going to criteria like this: as name. Okay. And then you're going to use / and then this, in this, what is this? What's the name of the sign? This is like exponent sign, and then J, and that. Okay. and this part, there's no single quote, double quotes around it. Okay, so this is just like as name, like percentage sign, like a J, and then percentage sign and J, right? So that's what is the query equivalent to. So what is this? This is actually in JavaScript, so-called called regular expression. So it's in general, it's a very powerful formula to search for text, but to get a full scope, you need to take some time to learn and to practice. But today we just do some basic ones. Okay, so just let you know that this what it's about. And then what if I want to do ends with? So if you want to say as name ends with and with n, for example, with small letter n. Okay, so in that case, you're going to do as name colon also / and then you put n and then $sign n. Kind of strange, right? So that is equivalent to as name like percentage sign and n. Okay, and what about contains? So have letter in the beginning or end. So as name has letter, let's say O. Okay, it has letter O. So how do we do that? In that case, you just do something not like previous one. So in this case, just simply put O inside and then / and there we go. Okay, so all of this are just regular for this JavaScript regular expression. Okay, so let me see what else you could you may encounter. Let me check. Does anybody have questions? So what I'm going to do, let's just try to see whether I covered all possibilities. Oh, I have not loaded your last review yet. Let me put that in. Okay, so that would be no, I don't even have it yet. Let me try to create one quickly. So will be so that would be week is that week 12 on the line? I already have it, but it's just not made available yet. So let me just do. So that would be notebook, database management, and the 641 week 12 outline. Good. All right, so let me make that available to you. Week 12 outline, okay. Now it's available inside your course material list. So this is week 12. Okay. Okay. So let's say let me see whether we have done everything. Oh, okay. So there's one more case. If you need to create, say for example, create like a document that you want to get. So we did something like that. Say for example, find the employee hired in which year, right? So we can use the higher year greater than something or less than something, and also we can extract a certain date, certain year number or month number from a date. Okay, so let me give you an example like that. Suppose I want to use create a document to say that the birth date is 2002. So this is what it would do. Okay, let me just put that in here. So both date. So I think what was b date, right? B date. That's the name of the key. That's a key. Okay. So b date has year number as 2002. Let's say that's suppose I have something like that. I want to create a document. So that document actually is going to be a little bit more complex. So first of all, create document. Okay. And then the document type is going to be just expression. It's a customized expression, expr. Okay. And colon. And then you're going to have actual operator. Close that. Okay, so this is embedded document. So basically, you're going to say this is like your customized expression. So expression in this case, I'm going to check, say whether the year from this birth date is equal to. So first of all, I'm going to use operator called equal. Okay, and then inside here, I'm going to have two values inside array. Okay, one of them is 2002, comma. Okay, and the second one is I would get the year from this birth date field. Okay, so in that case, I'm going to create another document, just document inside here. Okay, okay, and the document will be using the year operator, year. Okay, and the colon, and then we reference to this birth date field. So that will be $sign and b date. Let me just try to. Okay, this is. Hold on. Trying to get a eraser. Okay. Right. So we use the year number, and then we reference to the field name, which is a b date. Also put $sign in front of that, and that basically this part will give you the year number from this field. And then you compare that to see whether that is equal to 2002. And then I will close that with this. Okay, close this square bracket, which is, so this is array. This is array or list, right? So you're comparing this list has only two values, and then you're trying to compare whether they are equal. And you can close this one document. Okay, so your expression is just trying to say whether this year is equal to 2000, and then you let's close that, and then finally you close the whole thing. So basically, it's a kind of more complex query document. So I should actually delay that to the more general query documents. So the query documents we have been doing so far are all about equal, kind of like equal. Okay, equal. So what if it's not equal? Then if, say, for example, it's greater than or less than or something else, then we have to use operator documents. Okay, so let's just say, suppose I want to try to find like a student name in some kind of list. Okay, so we can use in operator. Okay, so the in operator it allows you to do things like, say, as name. Remember, in SQL we do in, right? And then you do some kind of parentheses here. For example, in John, comma, and then say Smith, right? Something like that. So something like this, and then we have to use in operator here. Okay, so what we do is we'll create the query document as usual. So first of all, the name of the field is as name. Okay, and then actual value is going to be like an operator. So we create an operator document. So operator document. Let me just put it here. Okay. Okay. And then the operator is in, right? So I'm going to say in. Okay. and then colon, and then you specify a list array here. So I'll put double quotes, John, comma, Smith. Remember, in JavaScript, we use double quotes instead of a single quote, right? And so this basically is checking, say, whether the S name is in this list or not. So let me try and see whether it's already closed. So this one is closed here, and then this one is not closed, so we need to close again. Okay, so that is query documents. So query filter document to use to do something like that. Just say so whether value is inside the list. Okay. Similarly, we may have something like say greater than, or this less than, and then greater than GT, and then greater than, less than, greater than, equal to. So that would be LTE, less than or equal to, or greater than or equal to. So we can use those operators, okay? And also we can use or operator. Let me do this first, okay? So let's just say, suppose I want to find the students whose birth date is before certain date, okay? So let's just try to do something here. Let's say birth date, B date, before December 31st, 2002, okay? So what do we do in this case? We create a document. First of all, the query will start to looking for the B date, okay? And then in this case, we do not specify this B date equal to some value, but we say it's bigger than this, right? So we have to create an operator document as a value, okay? And then the value will be, the operator will be in this case before, there's less than, so LT, okay? And then you specify less than what? So then you can specify a particular date, say is O date, okay? And then specify put date in here. So double quotes 2002 12 31. I'm going to do that, okay? And then close that. Okay, so that is the complete date. So it's bigger than that, and you can close the here. Okay. What if you want to say that B date is before that and after certain date, before this, but after 1999, for example. Okay, so if that's the case, you can just extend this part operator to include additional key value pair. So if I just say B date, so let me just give you a B date. B date between January 1st, 1999 and December 31st, and then 2002. Suppose, okay? So then in the case, you're still looking at B date, and let's try to create a document, okay? So B date is the field. Okay. And then we're going to specify this value, this criteria for this document, for this field. So then we're going to create a document for that. Okay. Create a document. So let's just close this first. Okay. So it would be easier to just type it, but here we just sometimes have to erase. Okay, so first operator is less is after. It's going to be after this date, right? So we'll say. After, that means greater than or maybe equal to, okay. And then we say is O date, okay. Let's put the values in here. So that would be 1999 and 0101 and comma. So this is the first is bigger than that. And then your second operator, which is LTE, less than equal to. And then for that, I'll use a different date. Okay, so I'll have to probably erase again. So this time we use 2002, 12, and 31. Close it. So then basically this is the value pair, and this is the value pair. Then we close that, and this whole thing will be operator. So when you do something like this list, then basically it will be considered as AND. Remember that, right? So that means bdate is greater than that, and bdate is less than this. Okay, and that is closing this document, operator document, and then for the entire query document, which is closed again. Okay, so that's how we use operators. And let me see whether there's any other operators we need to specify. Oh, what about or? Okay, let's do or situation. Okay, so let's say if I do or, or let me just say S name is Jones, okay, or B date is after 1999 January 1st, okay, January 1st, something like that. Okay, so in this case we are using or here, right? So so in this case we are starting with we are doing different fields. We're doing different fields. So we cannot start with a field. We have to start with this or first. Okay. So first thing, a document is or operator, and then colon, and then you put a square bracket for the rate. Okay. So we're going to have two parts, right? This part. So this part will have parentheses, the curly brackets for that first part, so which will be student name is equal to Jones. Okay, and then comma. Oh, no, that is one query document. Okay, close that and then comma. So this is the one entire query document, and the second query document is about the B date. Okay, so in this case we'll do say B date is after that. So this is not equal to. So we have to use operator document for the value. Okay, so let's put that inside, and the operator is going to be after, that's greater than. Okay, greater than which date? So let's just is all date, and then put that value in here. So parentheses 1999, and then 01, 01, something like that. Close that. Okay. Okay, and then make sure this is closed here, and this is closed here also. So we need one more here. So then basically, in this case, you are considering two query document, filter document, two filters. Okay, this filter and this filter. So it's linked by or. So that's how you use or operator. All right. So let's try. What if you have like a nested field? Let me show you an example like that. Okay. Suppose I have like something here. Okay. So let me give you an example like that. Okay. So suppose I have like a document like this. So it has item and it has a quantity. Those are usual. But then if you have like a nested document like this. So for example, for size has each size value is another document. Okay. And basically specify the height, width, and also ULM, that's the unit of measurement, right? Okay, so unit of measurement. So basically, you have a nested document inside. So this is very common, right? So you're going to have, employee may have multiple addresses, right? Employee may have multiple measures. Okay, so here size, you have multiple different kind of sizes. All right, so how do you query field like this? So for example, the size, the height or width or unit of measurement. So in those cases, you are going to use reference to the field slightly different using so-called dot operator, dot operation. So let me just say, I'm trying to, how do I do that? Let's see. So suppose you have a size, okay, which is like this, okay, like a height, say 10, comma, width 15, comma, and then UON is inches, okay, and then how do you reference to the field inside here? So for example, this field, okay. So to do that, you just simply use size dot width, okay. That's using dot operator. That's just pretty much like in object-oriented language, right? So basically this object dot this one, okay. And in this case, however, you have to put this inside, put the whole thing inside double quotes, and then you can do the value. Okay, so let's suppose I want to create, say size must be equal to 15. So then you do this width must be equal to 15. Then this is how you do that. Okay, so size the width equals to 15. And you can also do greater than, less than operators. So for example, if you want to say height is more than 5, height is more than 5. So what you will do is you will do size, and then dot, and then say h, and double quotes. And then here, since you're not doing equal, so you have to use operator here. Okay, so operator document. So in this case, we are going to use greater than, so GT greater than what? Greater than 5. Okay. Or if you have size less than something, then you could do together. So I'm going to just stop here. Okay. So in this case, you're trying to do height is greater than 5. Okay, so that's how you specify nested document field inside the embedded documents. All right. And I think let's just, let me see what time is it. So let's just try to do practice, and then if we need more, then we'll come back, okay? So at this point, I'm going to close that. And then just go to MongoDB and practice some of the examples here, okay? So first of all, let's say show DBs. So I have 1, 2, 3, 4, 4, quite a few DBs, databases. So I'm going to use MyDB. MyDB here. Okay, now let's say I want to show collections. Okay, I have 1, 2, 3 collections. We have students, we have sales, and inventories, right? So let's try to see what we have in students select collection, okay? So we'll do DB of students find. Oh, okay, I missed that. So find. Okay, so I have quite a few documents in there. Let's practice some of the examples I just illustrated, some of the query documents I just illustrated. So let's say I want to find a student who have no birth date. Okay. Students who have missing birth date. Birth date is B date, right? B date, yeah. Okay, so what we do is DB the students find the function first. The function is always end with like a opening and closing with parentheses. Okay, you can also put a semicolon here, but now let's move mouse inside and then go to formulate the query document, filter document. Okay, query filter document. So it's trying to like this, long name, but I just query document should be okay, or filter document should be okay. And so this is actually the place I was asking you to install what's called atoms. Atom is basically just text editor. So with embed, you can just have this command. There's a prompt inside that. But unfortunately, the installation was not smooth. And some people actually found that some people could not get it, especially with the latest version. What about Pinchen? Have you fixed that or not?
No, I haven't.
No, you have not. So basically, we could not use that. So basically, this is the place. If you have that, then it will be very convenient because you have this command inside the text editor, and you can just type and then you copy and paste. Okay. So we can still copy and paste, but but it's just a little bit not that convenient. So let's try to formulate that query document. So we are going to check, say, whether she's find those documents, find those students who have a B date, which is missing. Okay, so that's no. Okay. So by the way, when the textbook use capital N, that's incorrect. So just small letter n. Okay. And I copied that into my PowerPoint and then I found that that's wrong too. Okay. Okay, so here we have, do we find anybody? Yes, we found. Okay, so we find one situation like that. So now let's try to say we find, let's do, say, well, we want to find students who, whose birthday is missing, and also whose name starts with B, with letter B. Okay. So let me just put a question here. So students have missing birthday B date. Okay. And so this n, okay, and the what, and the name starts with letter B. Okay. So there's a forward slash. This is just like a okay. So it's just like a remark. That is same thing like a dash for Oracle. So if you put a dash in front of that, then this statement will not be executed. It will not be a statement, so this will be ignored. Okay, so same thing with JavaScript. Okay, so now let's say what do we do? Say db dot students and dot find. Finish that first. Okay, and now let's try to formulate the query here. Okay, so we are doing end. So we can just do straightforward. So each field value inside the query document. So the first one is B date, which is missing. Okay, comma, and then let's say the student name as name starts with letter B. So will be colon and a forward slash, and this is this little words tilde, and then it's not tilde. It's we usually just that for exponent, right? And then B, capital letter B, okay, forward slash, and then no double quotes around that. Okay. Here, so this basically you have two criteria, this criteria and this criteria linked by end. So you have end, just simply list every part. Okay, and there we go. Okay, so we found this basically the same thing. So now let's try to do equal, greater than something or less than something. Okay, so let's say this time I want to find student who have birth date after 1999 something, a birth date after 1999, and also name starts with name has something in there, or we may use some other criteria. Let me see. Just use birth date for now. Okay, let's say I want to find students born after 1999. What is that? Okay. So we'll do db students find. Okay. Close that first, and then let's formulate the query documents inside. Okay, query documents, and then for the query documents, I'm going to do just birth date, so B date. Okay, so B date in this case is we said is after 1999, so greater than 1999. So we have to use operator as a value. Okay, and then the operator document will contains greater than, and greater than what? 1999. So we can specify as all date parentheses. Okay, parentheses. Okay, so then we'll actually put like a text inside, right? And then we're going to put double quotes around that. And then we're going to put actual values. Okay, let's say to 1999. So I'll just say December 31st, 1999, maybe. Okay, 1999, December 31st. Okay, so we interpret that in this way. Okay, does it make sense? So what do we get? Those are the students have birth date after 1999, December 31st, 1999. Okay. And then let's try to use all this time. Okay, let's say I want to find a student who have a birth date after this date, or admission date is before 2020. Okay, let me put a question here. So we'll do students with B date after 1999 and or admission date. So what is the name of field? Admit date. Admit date. So it's case sensitive, okay? Case sensitive. This is different from Oracle. Oracle, all table name, column names are not case sensitive, but here for JavaScript, is everything case sensitive. So this is before 2020. Okay. So now let's try to formulate the document. Okay. So DB, students, find. Okay, finish that first. And now let's do the query documents inside. Okay, and since this time I'm using all, so have to they reference to different fields. So we have to use all operator first. And then use all here, and then colon. Okay, and then what is, so when you use all or equal, then you basically, we did equal, right? So all, basically we are comparing our values inside a list, or either this or that or that. So you can have multiple things linked by all. Okay, here we can just have two. Okay, so we create a square bracket for the list, and then inside here we have two things. One is birth date after 1999. So put that as a document, and this comma. Okay, and the second item in the list is going to be another condition, another criteria, which is the middle date is before 2020. So create another document. So you have two query documents embedded in the list, and then use all to connect them. Okay. So here, let's do the first one. B date. Okay, is what? After. So it's not equal. So of course we have to use operator document as a value. Okay. So what is operator in this case? Is after. So it's greater than. So greater than. Okay. Greater than what? The particular date. So let's just say ISO date. Okay. Parentheses first. And then double quotes first. Okay. Because it's very easy to make mistakes because there are so many different parentheses. But after if you get very used to this and practice a lot, and then you know where to stop. So here we are going to just, if I type opening ones, make sure you put the closing ones first. Okay. And then next one is 1999. So 1999 after. So we'll do December and the 31st. Okay. So there's one query document inside the list. And now let's formulate the second query document. Second query document is about admit date. Okay. And what about admit date? Admit date before 2020. So that is also less than operator. So we use less than operator. So close, opening, closing first. Okay. And then $sign. And then we do less than, right? Less than. So less than what? So let's just say ISO date. Okay. Then close it. Then come back, double close, and then come back, put actual date text. So it's 2020. And then let's just say maybe January 1st. Okay. So it would be nice if we have like a text editor to type the whole thing in a better format. Okay, I think that's it. That's how we use all. Okay, so you have to start with all operator, and then you put a list of query documents, and then you just see those either this one or this one. You can have more of this. Okay, more documents inside that list. Okay, let's enter. And we are okay. So we found quite a few. So yeah. So all these documents satisfy that. All right, now let me see what else we 42. So what if so we did I do every query documents here or possible? So in my lecture note, I have a list of examples, but given time constraints, we have like 20 minutes at the most. Let me see what I should do. I did all and okay. So there's an and all, so you can do and all in the same. So let's just try to do one like involving embedded document. Okay, so let me do this one. So let's see. Let me show you. Let me show the collections. DB. Oh, hold on. I think my okay DB, but I think there's something called inventory, right? Inventory and find. Let me see whether that has something for us to do embedded ones. Yes, it does. Okay, so let me tell you where to get that. So if you go to weekly note, week 12 outline, and then just scroll down to find say query embedded documents, and just copy that and run that. Okay, copy that and run it. So in my case, I will just simply delete it, and I will copy that also. Copy that. Okay, and then coming back to here. So first of all, let's say db dot inventory dot remove. Okay, remove, and then you need to put query documents inside. So in this case, we'll just have empty documents. Okay. So then everything will be deleted. We can actually also do drop the inventory dot drop the entire collection. That will be fine too. Okay, so now I can just copy. So what I will do is go to here, and then go to the top of the menu for this terminal. It's very limited, and then you go to edit and then go to paste. Okay, so then you can just run that, and then everything will be all documents will be created, and also the collection will be also created. So let me show you that. Okay, so that's db dot inventory dot find. Okay, so we get those documents. Okay, so we have embedded documents here. All right. So now they're trying to match those embedded fields. Okay. So let's say suppose this time I want to find documents, find articles. Wait, what is it called? Items. Okay. Trying to find items that have let's say that has a weight bigger than 20. Okay, find the weight bigger than 20. So what we'll do, db dot inventory, okay, dot find parentheses. Okay, semicolon. We can finish that first, and now we go back inside trying to create query documents. Okay, and then let's say we formulate the query document. So here, so let's say I want to find the weight. So to reference the weight, this field, we have to use size because that is actually part of a size, right? So we have to do size dot weight. Okay, and then remember, if you use dot operation to connect fields, embedded fields, you have to put inside double quotes for the name, for the key name. You have to put inside double quotes the name of the field, reference to nested field. So you have to put it inside double quotes. Otherwise, it's not going to work. Okay. All right. So now let's say I want this weight to be bigger than 20. So it's not simple equal to some kind of value. So it's not equal to. So we have to use operator documents to create greater than, right? So operator, which is greater than what? Greater than 20. There we go. Okay. There we go. So find that. Let's do one more time. So this time I want to find, let's put here, okay, items with height. okay, with the height over let me see what kind of height, over 10, okay, measured in inches, in centimeters, okay, measured in centimeters. Does it make sense? So we want to be height over 10, but also we have also specified unit of measurement, okay? So in this case, of course, has to be n, right? So this and that, right? So we'll have to create like a document consists of 2 fields. Okay. So we'll do db at inventory dot find parentheses first, okay, and then go inside, create a query document, and this query document is going to consist of 2 parts, right? 2 parts. So it will be separated by comma, okay? So the first 2 value keys, okay? The first part is height over that. So for the height over that, we'll do size.h, okay? And then colon, and then say greater than that. So if it's greater, so we'll have to use operator as a value. So now we formulate that code, the operator here. So that would be greater than 20. And then we finish the first part. Did I close it correctly? No, not yet. So I think we have to we have to have one more square we'll call it brackets here. So look at here, this is operator. Okay. And then this is for the whole value pairs. Is it correct? No, we do not need that. Do not need that. Okay, so we just do this. We do this key, and this is the value. Stop here. So now we do the second field. Okay, let's go to second field, which is about measurement, unit measurement. So we'll do size dot UOM colon. So what is that? In this case, it's simply just equal to centimeters. So equal to, so that will be simple. Simply say centimeters without using the operator as a value. Okay. So now let's try to look at the whole thing again. So here, this is closed, right? As a whole function, parentheses. And then inside we have one document, that's a query document, okay? And which has 2 value pairs. And those, when you have something like that, will be interpreted as AND. So this condition and this one, okay? Otherwise you have to use OR, right? So then you have started with OR and then do like square bracket. So there we go. And then this is how we refer to embedded documents. Okay, hold on. There we go. So we got one field like that, and one document. Good. And what if you want to say at this point I get basically all entire document, all fields in all key value pairs inside the documents as a result? But what if you just want to show certain field, certain key value pairs, not all of them? So in that case, you will use something called a projection. But last class I showed you how to use a print JSON to do it, right? So use like a for loop, right? For each, and then you create a function, and function will print a JSON, and then in JSON print, you just create a list, say which one you want to print, okay? But actually there's another way to do it, and probably is simpler way. So that's basically using like a so-called projection field. So what is happening here is you do db that. So for example, inventory that find, I said you will create one query document inside here, right? And that is not completely true. You can actually have another document, and the second document will specify which fields you can put in. Okay, you can have second parameter. So second parameter is optional. So the first part is still query document. So you specify condition like what you have before. But the second part, you specify which fields which second document is a projection document. the projection document will specify which fields you want to be displayed. Okay, so now let's do one example here. Let's say I want to find all the documents in measurement as centimeters. Okay, but then this time I want to show only few fields. I want to show fields, for example, item field, quantity field, or maybe status field. Okay, or we can also do size field. So but let's just do the query document first, which is measurement of unit, which is size.uom, and that is equal to centimeters. Okay, so that is a query one. Okay? So that part is just, you can just do whatever we just did before. Okay, so it can be any query documents. And then so let's just focus on the second part. The second part, basically, if you do not specify ID field, this ID, the ID field will be displayed by default. Unless you want to say, I do not want to display ID field, you turn that to be 0, then that ID will not be displayed. So basically, every document automatically has ID, right? This object ID here, this ID, ID here, okay? So if you make the ID equal to 0, then that base ID will not be displayed. Okay, but if you say ID equals to 1, that means the ID will be displayed. Okay, so let me just do either way. Okay, do both ways. And then this is about ID. ID is by default will be presented by default. And then for any other fields, the items you want to be displayed, you put in. Otherwise, you just skip them. So basically, just like a select statement. Okay, I select ename, comma, job. Then I only get a ename column and a job column, right? I will not have hire date, salary, some other fields. Same thing, pretty much same thing here. Suppose I want to get item field, and I will turn that to be 1, okay? And then comma, if I want to have a quantity field, and also turn that to be 1, okay? So 1 means I want to show it. Okay, so do you put that as 0? No, you don't, because if you say 0, then you simply skip that. Make sense? Okay, so just the ty is 1. Okay. So we'll be showing just item and quantity in the result, and also ID that's in the result, and then for this query. Okay. So now let's see what do we get. So there we go. So we have just showing the ID and item and that. So let me just go pull up the query. Let's change to 0. Okay, change ID to 0. Let's change that to 0. So I use arrow key to pull up the previous comments, and then I can make changes in there. Okay, so this time you see that this ID will be suppressed, right? So that's how you can use a projection document along with query documents to restrict the result. Okay, to select certain results. All right, and let's see. Let's try to do one more thing. That is, so let's do like a group function, like aggregate statistics. Okay. For that, we did like a group by and then doing statistics, right? So let me show you what is the syntax first. Instead of typing, I'm going to just show you what is the syntax for that very quickly. So here is a format, here is a syntax. Okay, so first of all, you can still use those so-called group functions. So max, mean, okay, standard deviation, sum, and forced average, all that, right? And that's so-called aggregate. It's called a cumulative operator. So you can also create your own. So for example, you want to do some kind of complicated statistics, you can write things to create your own statistical function. Okay, and so this is basically group by and having a group by format. Okay, so so let's understand that. Okay, so when you use this so-called aggregate, and you put that inside as document. Put this as a Word document, as like a group by document. Okay, and the group by document have this syntax. So start with operator called group. Okay, and then how do you group? So basically you group by so you will do group by, you're going to get like a create a result, and the result will have sorting field and sorting key values. And the first one is ID field. And then, so this basically just say group by what? Group by what, you know. So for example, if I do not want to group by anything, then you just leave that as a missing values and null value here. So there'll be no group by, okay? But if you want to group by, for example, department number, then you put department number here as group, as expression. Okay, and then if you want to group by job, then you just put job field, okay, as expression here. So exactly how do we write a field, and just wait, okay. And then second, and then I'm going to do statistics, right? So for example, I want to do count, do sum, and every time I do that, I will get like a field, right? So give a name for the field, okay, give a name. So this is what like a sum of salary as something, right? So that is something here. You put that name here as something, okay? And then you specify, say I want to use sum operator or average operator, so specify that, okay? Or your own customized operator. And then there's some or what count will be applied to this, for example, columns or some kind of a calculation, some kind of a multiplication expressions of columns, okay? Or field. So basically this is expression again. Okay, so let's try to trying to do this do a couple examples. So basically it's pretty straightforward, I guess. Okay, so so I'm going to, so basically this document, okay, this whole document, we'll just do group by and also we'll do this calculation, okay. And then if you want to do like a heaven, then you do another document called a match document. And after this document, just create another one, say match sorting field. For example, sum is greater than something, or average is less than something. So then you create another match document. Okay, so let's just do the first group by document. Okay, so let me pull this back. Okay, so first, let's see whether we have meaningful data for that. Let's say show collections again. Okay, so I do have a sales, so I'm going to drop sales and then going to create a sales. Okay, db.sales.drop. Okay, so I'm going to drop that. Okay, so what I want you to do is at this time you just go to week 12 outline. Just say lecture 2 aggregate statistics, right? So just copy this code, this script, and then run that. And I'm going to, so let me just explain this a little bit here. So basically this one has item equals to that, right? So this document, each one has item, name of item, and the price. So the price, you can just simply put a 10 or 20, but this one is kind of put like a numeric number, decimal, and then number, integer, or something like that. So that's just say this text will be converted into these numbers, okay? So then you understand the use of date. So everything else should be straightforward. So let's just copy that and then go to the Mongo to paste that and run it, okay? So now let's say we should have, let me see, db.sales find. Okay, so we should have a couple of sales items, sales records. So basically each one have like ID, okay, and then have a say what item, the name of item, the price of that item, and the quantity of the item, something like that, right? So let's just try to do like an aggregate. Okay, so this time first thing is simple. Let's just say I want to count how many items we have. Okay, so in this case I'm not going to do group by. Understand? So I would just simply say doing something like a select count from sales, something like that. Okay, so to do that, you're going to do db, okay, db.sales, okay, and dot aggregate, okay, and then parentheses, semicolon, okay. So basically just like a find, right? But this time I need to formulate the group by group document, the group by document, and the group by document will be just like a regular document, okay? And you will start with operator called a group, okay? Cool. Okay, so now let's decide how we're going to do group, okay? What field to be grouped by, and what field to be used, to be the name of the field to be used, to be created. So that will be another value document for the group. Okay. Okay. So inside, I'm going to create basically just like a list key value pairs. The first one is always unique. That is, say for that after you get the result, what is ID field, right? So I will say the ID, okay? So actually that is actually specify whether you want to group by anything, okay? So if you do not want to group by anything, then just leave that no, okay? So that's basically saying that we'll create a group. The group label is missing. There's no group label, okay? So we'll say group by department number or group by job. So the job or department number will be like a group label, right? So in here we do not have any label. So that means everything will be just in one group. Okay. And now let's say we want to just do count. So first of all, let's give a name for the new count result. So let's just say this is count. Let's just say item count. Okay, item count. Create that. Okay. So that's just the name of the column you create. And then actual data, actual calculation. Actual calculation is going to be like using the statistical functions, right? Statistical operator. So I'm going to create operator document inside. Okay. So this field, this new field I just created will be based on this operator, this statistical operator. So we are going to, there's no, I don't think there's a count. So what we do is just simply just like a sum of ones. Okay, so we use sum operator. Okay, and the sum over one, just value one. So each document will just have value one, right? So that would be equivalent to the count. Okay, I don't know why there's no count operator. Okay. Anyway, so now let's just see the result. Okay, so that will make sense for you if you see the result. Okay, so you see that there's no group, it did not group by anything, right? So the value is null, and then item count is 8. So that basically just total number of items here. Make sense? Okay, now let's do one more. So this time, let's say I want to do count again, but I want to group by item name. Okay, so I say how many ABCs, how many XYZs, something like that. Okay, so let's do the same thing here. DB, sales, aggregate. Okay, parentheses, semicolon, and now let's put inside group operator document. Okay, so first of all, I'm going to do group. Okay. Okay, and then we're going to specify the value for the group by and what statistics we want to do. So I'm going to put inside a nested document in here. So first for the ID, so that is label for the group, I will use item. So how do we do item? So we're going to do this how we reference to the column value, the field value. Okay, use double quotes first, and then put item, the name of the field. Okay, and we need to use so basically if you do something like this, you understand that this is what this is just like a ID equals to this value, right? Equal to this item, which is text, right? So we have to put a $sign in front of that. That will make sure that you are referring to the column field value. Okay, the $sign and then the name of the item. Okay, so they're basically saying that we are doing a group by item, group by item name. Okay, so after that, comma. So now let's specify statistics we want to calculate. Okay, so first one, I will still do item count. Okay, item count. And then let's say item counter will be, in this case, will be what? We do the same thing here. Okay, so just say using this group statistics, which is sum, and over 1. Okay, over 1. Let's do one more. So in this case, let's say suppose instead of just a count number of items, I also want for each group, for each item group, I want to count what is average price. Average price. Okay. Does it make sense? So we are going to create second one. So just make sure that you know where to type. Okay. So here, this is group label, group by, and then this is more like a select count, right? Count. I will start go all the way to here. So stop here. Okay. So I need to put a comma here. Okay. That makes sense. And then let's create a new field which will be showing the average price. So I will just name that as average price. Something like that. Okay. So for the average price, it will be calculated by this operator document. Okay. So the operator in this case is going to be average, right? So just say average. This is the operator name. Okay. Average, and then average over what? Over price. So put that inside double quotes first. So price like that, and then put a dollar sign in front of it. Okay, so that is how you calculate average price. So basically, just the average of this. Okay, so only thing that is a little bit different is a little bit cryptic is that to reference the filter name, you not only put double quotes, because if you simply put double quotes, that's just name of the value. That's actually the value, right? Text value. But then you put dollar sign in front of that. That means you're referring to the value of that field. Okay. And so in this case, we do group by item and select count and also average price. There we go. Let's try that. Okay, so there we go. So we get 3 fields. This is a group label. An item count is 2. Average price is 7.5. Blah blah blah. Okay, so that is how we do group by. Okay, so you know what? Let's take a break. And during the break, I'm going to give you like 20 minutes this time. You're going to use like 10 minutes to do teaching evaluation and then 10 minutes break. Okay, so I will be back like 8:29 or maybe 8:30. Okay, so let me tell you where this. Let me temporarily resume. Okay, so I'm going to do. So I'm still in MongoDB. Okay, find the total order amount for each item. Okay. So what we do is we do db.sales and .aggregate. Okay, and then we put parentheses, just name a function first, and then let's do group document. Okay, do group by document. So put that group by. Okay, so first of all, specify that it's going to be group. Okay, and then how the group document will be specified. Say I want to group by ID, so by item. So the ID group by label will be just that item. So we use dollar sign and item. Okay, so that part is easy. Right? And then the main part is I want to find total amount, right? So let's just say total amount like that for the item. Okay, so for that I need to apply statistics. Okay, so put that first. Okay, put that. So which operator we're going to use? So we are going to do sum, right? Sum over the order. So each item has like a quantity multiplied price. That would be subtotal. Then we sum over those subtotals. So let me just say I'm going to do sum. Okay, and colon. Okay. So now let's say sum over what? So we have the proper create expression. So the expression is going to be inside another document, will be another document. So this time expression is going to be just multiplying. Okay. So I will do multiply. Okay. And multiply what? Multiply. So we have to provide numbers to be multiplied. So we'll put that inside the list. Okay. So the two items to be multiplied will be price and the quantity. Okay. So step by step, you see that how we do this. Okay. So we find the total amount for each item. So each item has like a quantity and also price. Then we get the subtotal. So we basically sum of the subtotals. So how do we get the subtotals? We use this expression multiply. Okay. And now multiply two things. So first one is the double quotes first, the comma, and the second one double quotes. Okay, let's finish that first. Hold on, it's double quotes. It's not the colon here. Okay, so we're going to multiply two things. One is price. So let's put that inside. So dollar sign and then price. That is the name of the field, right? So this field. Okay. And then the second item, second thing to be multiplied will be the quantity, this one, okay? So we just put that inside the second one. So quantity, okay, quantity. Okay, so then this basically just have a group by, and then, so it's equivalent to find the total amount for each item, okay? So then after that, I will do match one next, okay? So let's see whether this one works. And so it works. Okay, so find the total amount for this item, which have that. And for this item, the total amount is that, so on and so forth. Okay, so now let's say, let's pull up the same document again. Just use arrow key, pull up, okay? So this time I'm going to create, so this is the first document is a group by document, and then we're going to create a second part, comma, and the second part is going to be do matching. Okay, so the match in this case, I'm going to matching document. So start with matching. So match, yeah, and the colon. Okay, and then what do we need to match? So we need to match that this total amount is greater than 100. So we need to create another query document inside. Okay, and the query is total amount. Total amount is the same name as this one. Okay, total amount is greater than 100. So that's not just simply equal to some value. So we have to use operator document to specify greater than. Okay, so that will be GT greater than, okay, 100, something like that. Does it make sense? So this is having clause. So basically, the first aggregate will group by this item, and then for each group we'll calculate this like total amount, and then the second stage will just check see this total amount is greater than whether any one of these is greater than 100. Okay, so that's it, and let's run it. So we get a 3, right? Yeah, that's indeed. So 1, 2, 3. Okay, so that's that is group by having completely comparison. Okay, so I'm going to stop here, and let's. Do you have any questions about this? No questions. Okay, so I'm going to quit here. Okay, and then we can exit that out. So let me look at the review list to see whether we have any questions on that. So let's open up review questions. So let's go to here. Yeah, let me just go back. Okay, and let's see. I think I posted a review last night or maybe before. Let me check. Yeah, review for final exam. Okay, so let's do that. And let me move this up to here. Okay. So basically, list all the things, basic concepts, like a structured query language. So what do we, basically this is a list of things we learned. Okay? And for MongoDB, even though we have only like a 1.5 weeks class, but we covered quite amount. So everything we did here, basically embedded fields, query array fields, and aggregate. So we did that, right? And those are the concepts we did in the previous, in the exam one, previous exam, I believe. Okay. And then for techniques, just make sure those are the things we, just sounds familiar to you. I think you should, those pretty new ones. We pretty new. We basically, we're doing SQL, and then every SQL we're using some kind of basic ones. So I think you should have very fresh memory of the things listed here. And then let's look at some of the example questions to see whether you have any. So sample questions, I have those some SQL statements and MongoDB, and also have questions from previous exams. So I'm not going to go. Do I need to go over that? We may be, okay, we may. So let's say for SQL, since they are very familiar to us, we probably can just skip some. So you understand the where class, right? Where class is basically say you have observations, you select observations, right? And heaven is for you to select, those particular like factors, right? So for example, you group by job, and then say for each different kind of job, and you want to select, those types of jobs which has different values. So anytime involving using statistics like a max, mean, average, count, all that, those conditions must go after heaven, okay? But if a condition is reference to individual column values, then use a where clause, all right? So that's difference between where and heaven. And then let me skip that. So some of these questions, how many do I have? So I think some of the questions are pretty straightforward, especially the beginning part. This few just, simple ones. And then some maybe a little bit more involved. Let's see whether I can pick up some more involved ones to do a few examples. Okay, let me see. So 29, give $500 salary increase to the person who have smallest salary in the company. That's easy, right? So basically just say update EMP set cell equal to cell plus 100, and where salary, the person's salary must be smallest, so equal to find subqueries. In subquery, find the minimum, right? But then this one is a little bit different. So this one is doing something like a given $500 salary increase to all the employee who has a minimum salary in his department. Okay, so that's different, right? So that one, we can do it here. Okay, so let's just say if I needed to do it using, I will just do it in whiteboard, okay? Just refresh. Okay, so let's say we want $500 increase. So basically you're going to do update EMP and then set cell equals to cell plus 500. Okay, so that's probably easy. Okay, and then we want to do that for whom? For the employees who are making smallest salary in his department. So somehow we need to use this employee reference to this employee's department to get the minimum salary. So here we have to use tuple variable. So I'll put maybe like an A here. Okay, put A in there. And then here that will be A dot cell equals A dot cell. All right. Update that update EMPA. Okay, and then we do well. Okay, so for this person's salary, A salary must be matching whom? Matching minimum salary for A's department number. So that is subquery we need to fit in, right? Okay, so let's do that. Okay, so we're going to replace that by subquery. So we're going to say select minimum cell from EMP, and then where this for the salary we want to calculate, the minimum salary for the department number is equal to a.dept number. So just replace that, put into the subquery. Okay, so that is answer to that question. All right, you can stop me if you have questions. Okay, so otherwise I will just move on. And then next one, 35 employees who making less than their respective department average. I think we did something like that in class, right? Anyway, so basically you're going to use two variables again. So basically just like this. Okay, I'm going to do it. Let's do it up quickly. Okay, so we want to find employee. So we can select start from EMP. So we have to use this employee's department to find average. So we have to use tuple variable again. Okay, from then where. Okay, so a dot cell is less than average. So what we need is find average salary for A's department. Okay, so pretty much the same thing like this one, Okay, so instead of minimum, just say average salary, put in here. Okay, so I'm going to skip that. All right, and then so find the names of the employees from two largest department. Okay, so whenever you have this kind of question, largest, smallest, or rundown, so just make sure that you create a subquery first. Okay, trying to reshuffle the things and then get the first two rows. So either the reshuffle by rundown number, reshuffle by some kind of like a order by class. So order those employees, order the result. So here we are looking for largest department. So apparently we need all of the departments by their employee number, employee counts, right? So we have to use a group by. So whenever involving like a count, sum, whatever, so you have just don't forget you need to use group by. So let's do that. Okay. So first, I'm going to get list of department, select DEPT number, okay, from EMP, because I need to use count. So can I use DEPT? If you use DEPT, then you can have the join, okay? And then we are going to group by DEPT number, okay? So at this point, you know that we have groups, but now we need to order these departments by their total employees. So order by count number of employees. Okay, so let's just try to do descending order because we are trying to find the largest department first, right? So this by after reshuffle, and this will give you the department numbers ranked, ordered from top to the bottom in terms of their number of employees. And from here, I will be able to find the top two departments, right? So to do that, I'm going to say select DEPT number. Then from here, from this temporary list, and then we say where row number is less than 3. Okay. So this whole thing at this point will give us just top two departments. So I'm gonna put that inside the subquery. Okay, so then let's just try to finish the main query. So I'm going to erase some part of it. So what I did, put the wrong thing here. Okay, so I'm going to erase something on top. Where am I here? Okay, this part. Okay, so I'm going to erase that. Okay, so let's see. So I already know the departments. So now I just need to find the employee names from this department, right? So that's easy. So we're basically just say select name. Okay, from EMP, okay, and say, well, DEPT number in this list. And there we go. So that's how how you solve this question. So basically you have like a two nested layers of subqueries. So sometimes questions like that appears to be very overwhelming, but if you just do starting from very internal one, basic ones, step by step up, and then you should be able to do them I think it's pretty straightforwardly. Okay, so I'll skip that, and now let's see whether there's any other questions. Okay, so we did this 42, 33, find the employees with a rundown job title. Do you know how to do that? Find the employees with a rundown job title. So you need to find a rundown job title, right? So it's just trying to select a job and then trying to pick up one job, okay? And then you say select employees, the job equals to the rundown job, right? Does it make sense? Do you want me to do it? So in that case, just first, so I can find the rundown job, right? So that's easy. So just say select job, okay, from EMP, okay, and then we just order by TBMS underscore rundown data value. So basically you have a list of jobs and now reshuffled, okay, reshuffled. And now you just need to find one from that, find one from it. So you're going to say select job from this list, okay? And then say, well, row number is less than 2. So this whole thing will give you just a rundown job. And after that, the main query, just find the employee who have this job. That should be simple. So select ename from EMP, and they say, well, job is equal to that, okay? Okay, so that's a rundown job. Find the rank of each job titles in terms of the total number of employees. Okay, so again, since you are going to do total number of employees, you have to do group by, right? And then group by job, and then count, and then you do rank of the job. Okay, so if we do it, so we can do that quickly. So here we're going to do select job, and then count. Okay, so let's do that first, okay, and then do rank next. So from, and then EMP, okay, and then the group by job. All right, so that's the basic ones, right? So we can also order by, so that's not really necessary, but if you want to see the rank in like some kind of order, you can do that, order by count, star. Let's just say we do in descending order. Okay. So basically this will give you just list of job and the accounts. Okay, so now after that we just attach rank over. Okay, and then here is you put something here, like order by count, star, and also descending order. There we go. So then that's what you're looking for. Okay, so just remember the keywords here. You're looking total number of employees, count, sum, whatever. So then you have to use group by. Okay, don't forget that. And the list is job title along with employees who has the job title. So basically in this case, you're going to do like a cursor, right? So let's do that quickly. Here. Okay, so we are trying to get select job. Okay, and then here I want to find the employees who have that job title. So I will say so in this case we have the two variables again. So let's say EMP A, okay? And then we put A's job here, okay? A's job. And then I'm going to put cursor here. And then here we say select ename, job, maybe salary, whatever, from EMP, okay? And then we have to make sure that this these employees you select have this same job, have this job, okay? So well, and the job must be equal to a dot job. Make sense? So that will give you all the employees who have A's job. This job. Yep. Okay, so that's all SQL questions. Let me see whether there's any other questions here. Okay, so this is a text search. Okay, so suppose you have like a some kind of table with a column shows large amount of document, large document like articles. Then how do you search for those words? And suppose you are given a table for a national organization and it's a constituent sub-organizations. Write a SQL statement that query table to display the organization in a hierarchy. Okay, so basically this is hierarchical recursive query example, right? So basically we want to show that so national organizations supervise, maybe state level organizations, and then state level organizations consist of, city level organizations, and then trying to create them in a hierarchical order. Okay, so that basically is just same kind of like a use of ways. Okay, just get into the first level national organization first, and then you go from there. You go to you find the employee, find the organization supervised by that, and step by step to build the table. Okay, so that's just kind of like an example we did with employees in command structures, right? Command chains. Okay. So write MongoDB queries. So basically I give you these documents, you create them, and then just write the statements, So those are pretty simple ones, I believe. Now regarding prior ones, let me see whether we can pick up some questions for you to get it reviewed. Okay, so let's say in this case we have a. Did we do this as homework? I think we did that, right? So each you have we are given a bunch of tables, and the table has a primary key. You should identify, for example, member ID as primary key, student ID, professor have this ID, right? And then looking at each columns. See, this table has student column and professor column. Just by the name, you recognize that those are foreign keys, right? Because you already have tables like this. Professor table, student table. So this is probably the student ID. This probably just instructor ID, right? So similarly, if you look at the student table, it has all the mission data and also have faculty advisor. So that's probably a professor's ID too, right? So that's foreign key also. And then memberships. So memberships has a membership number and expiration date and member here. So this member has this member. So apparently this is a foreign key, right? So based on that, you can just tell that this is probably just like a weak entity from members. Okay, why? You can just imagine that a member may have multiple memberships. They are expired in different times, right? So this year you have a membership, next year you're going to have a different membership, maybe have a different number, but then you are going to have a, you're going to reference to the member ID for that membership to be recognized, okay? So this is the weak entity. So if you're going to draw ER diagrams, then this ER diagram will look like what? Let me see. So you're going to have, so first of all, you're going to have a members. And then you have a memberships. Okay, and then you're going to have weak entity here. So weak entity always have like a there's a little bar on the weak entity side, one-to-many relationship, right? So you have a member ID here, this ID, and then here the membership also have a, you're going to just have just regular number. Okay, that's a part of a primary key, but then when you create the tables, then you have to make this primary key as a foreign key here, and also that the foreign key will be part of a primary key for the table, right? So that's how we have this situation that this membership is going to have this member and a number both together as a primary key, but the member here is a foreign key coming from here. Okay, and then you also notice that these members have student and professor. So basically, this is what this is probably like a weak entity here, right? So you're going to have a student inside. Let me put the ERD here. So you're basically going to have a entity for student, and then entity for faculty or professor. Okay, so that's why that's how you can get it. Say we do like arc implementation, you're going to duplicate the primary key from subtype into subtype, right? So if each sub entity already have ID, for example, you have student ID, you don't create one, and faculty ID, you don't create one. But if a professor student does not have ID, then you have to create one. Okay, you have to create one and then put the ID into the main like a super table, right? And then so that's how you get those. Go back here. I'm trying to close something that I do not need so that I don't get confused by so many windows here. And let's go back here. So that's why you get this, two columns, two foreign keys coming from here. All right. And also you have student have foreign key from professors. So what does it mean is that you probably have a relationship between student and faculty, and that relationship should be one-to-many, right? So that's how you can get a primary key from one side into many sides. Does it make sense? So then, you convert that into relational table, then you're going to have a primary key from professor coming to student as foreign key, right? Okay. And now let's see whether there's anything else. So that's how we get those things covered. And now membership already weak entities, we said that. And then let's say events. So events, basically you're going to have a name and a time as a primary key. So that two column as a primary key, okay? So then you can just create events, okay? Let's just put it somewhere. Let's put events somewhere here. Okay, let's just say events here. Okay, event, just singleton. And then event have a name as part of a primary key, and also have a time, also part of a primary key. Okay, so that would be, and then there's any other fields, just put in, that's just, there's no foreign key, anything. But then we have another one called a sign up. So if you look at a sign up, there's a member, that's probably foreign key, that's coming from here, right? And then there's an event name and a time. So that's clearly there's a foreign key also. So it's coming from here, okay? So essentially you have many-to-many relationship between events and then members. So that's how you get junction table, like that, okay? Duplicating primary key from both ends into the junction table for many-to-many relationship. So that is kind of like a warm-up of your entity relationship diagram, and also how do you convert relationship diagrams, okay? How do you convert? So basically you have one more example to do that, so practice that. And next, let's try to come up with example to warm up your normal forms. Okay, so let's do the first one first. Okay, this one. Does the following table conform to Boy Scout normal form? So to do that, we need to understand that the Boy Scout normal form says that if you have a determinant which is not a key, and you're going to have violation. So apparently we can easily identify this has a violation, right? Because account number determines the balance clearly, right? Each account has one balance, right? So So now we have functional dependency between account number and the balance. However, is account number key here? So now we have to think of the situation here. Okay, so the table has customers and account numbers, the balance, and also last transaction. And you can just, based on common sense, based on our knowledge on ER diagramming, so cardinality stuff, we can just recognize that one customer may have multiple accounts. Let's check on that, okay? So does one customer have multiple accounts? Let's see. So 9081, it has only one account. 2098, this one, 2098. So indeed, this customer and this customer has two accounts, two separate accounts. So that means one customer can have multiple accounts. Okay, so on the other hand, one account may have several customers, right? Joint accounts. So let's check on that, see whether that is true. So indeed, we have like a 375 and 375. So they have two customers here, right? That account. So indeed, between account and customer is many-to-many relationship. So if you have that situation, then account number cannot be key. Okay. Another way to tell that is because account numbers are repeating here. There's 375, 375, 375. So repeated 3 times. So account number cannot be key. So therefore, this table violating Boy's account number 4. Does it make sense? So how do we fix that Boy's account number 4? And we just need to, let me go to whiteboard again. So first, I'm going to use account number determines the balance. Okay, use that. Basically, this is the one say the determinant is not a key, right? So as the table is not in Boy's card normal form because account number is not a key. So to be a key, then the value has to uniquely determine every record, right? So basically, you can use that as a primary key. Okay, so it's a candidate key at least. And now let's fix. Okay, so how do we fix? First of all, we use that to make a new table, account number, and the balance. To create a new table. So this will be transistors. So I'm going to create a table with account number as primary key and the balance as non-key column. And then next, and I'll have to use everything else. So let's look at the original table. Everything else in this case will be just customer ID and the last transaction, right? Last transaction. So let's say, so everything else. So we basically have a customer ID and the last transaction. Okay, last transaction. And then we have to add this transistor back. So account number back again, right? So now we have 2 tables, okay? And then the result of that is not clean, may not be clean. So you have to do it again, okay? So for this one, I don't see any problems because there's only one functional dependency. And for this one, do you see any functional dependencies? So the only thing I can tell is that this account ID, if I know the customer and also account number together, it determines that. But then this is already primary, is already key. So therefore, this is already Boy's account number 4. Okay. Some of you may just think that what about is it possible that account also determines last transaction? And we need to check. Okay. So let's say for each account number does have a unique last transaction. Let's see. So let's say 375. Last transaction was 98, and then the 375 last transaction was 97. So no, this account number does not uniquely determine last transaction, right? So put into context, put into like a meaningful context. So basically, if you have account, the account may have multiple customers, and each one of them may have different transactions, right? So for example, I may just, withdraw money, and then my partner may also just like deposit money. So each may have different transactions, right? So that actually the transaction will depend on both. Does that make sense? So for first, second, third normal form, let me see whether we have examples for that. Let me see this. The table is, the document is too large for this screen. Okay, right here. So we do have a situation like that. So here, I think we did this as a homework, I believe. So we have a customer ID, customer name, and a salesperson, sales region. So apparently, customer ID is the primary key, right? Okay. So if you know customer ID, then you know the customer name, and also you know who is the salesperson responsible for you, and then which region, okay, you are located, the salesperson located. So primary key is that. However, and we have 3 non-key columns. Then we can easily identify that the salesperson determines region, right? Because if I know salesperson, then I know the region, which region he or she works for. So therefore, we have a non-key column determines another non-key column. So therefore, this is a violation of third normal form, right? And then let me try to get you one more example with first, second normal form. So let's say equals again. Let me see whether I can find the one easily. So too much here. So let me see whether I can find something like a week 7 on the line. Okay. All right, so this is this table. Did we do this as homework? Did we? So here, if you look at here, the transaction has multi-values. The address does not have multi-values, right? Because you just say if you look at each row, okay, and then some of cells have multi-values. So this one has multi-values, right? Okay. So you need to single those 3 columns out to make it like a weak entity. Okay, so the 3 columns, and along with original primary key. So you need to remember that you need to duplicate a primary key from the weak strong entity to that, right? So what should be the primary key for this table? So basically, is information is information about the customers and account. Of course, you have to use both ID and account number as a primary key for the relationship, right? As I explained in the other example. So then you have to duplicate the primary key ID column and the customer number column into that separate weak entity table. So then the separate weak entity table is going to have 5 columns: ID, account number, and the transaction number, and transaction type, and the transaction amount. Okay, and then that will fix the first normal form. Okay, and then everything else left over. So that includes all this ID, name, account number, balance, account row, account type, address will be make a separate table. Okay, and then after that, you realize that this table, the table you just get for the strong entity, but which has ID and account number, balance, all that, you're going to have violation of second normal form because you're going to have a balance determined on account number only, but account number is only part of a primary key, right? So you're going to have violation of second normal form. Similarly, name depends on the ID only, and then account owner rule depends on both, I believe, right? So if multiple customers have the same account, and then maybe one customer is a primary customer, someone may be secondary customer. So that depends on both customers. But account type depends on the account number, and address depends on the ID, depends on the customer ID only. So you're going to have a partial functional dependencies. Okay, so you need to fix that second normal form. All right. So I think that should be enough for warming up about things we did before. Okay, I think for our first exam we covered what we covered. We covered all data modeling stuff, translating ER diagrams into relational model, and also I think we did some part of a little bit of normal forms, but not a Boy's card normal form maybe. Okay, but in general, so that's just like a warming up of everything. So some of these questions you probably want to just take do it again, try to understand them again. So you may have a better understanding this time. Okay. All right, I'm going to stop here, and then I'm going to ask you questions to see whether you have any ideas. So we're going to stop recording for now.